Number 38, determine the empirical formulas for compounds with the following percent compositions. And then we have a big one, guys. We got to find an empirical formula with the percent compositions of 28.7% potassium, 1.5% hydrogen, 22.8% phosphorus, and 47.0% oxygen. Okay, so percents, two empirical formulas. How do we do it? It's an easy 4-step process. And here are the rules right here. So I'm just going to make this a little bit smaller, mainly because we have a lot going on here. We need 4 different elements, so I just need a little bit more room. But yeah, so here is the 4-step process, all starting from percentage all the way to empirical formula. All right? So the first thing I'm going to do is I'm just going to list out what I have. So let's see, I'm going to start all the way over here. I have 28.7% potassium. I have 1.5% hydrogen, and maybe I can, actually I think maybe I can fit them in. Let's see guys. Actually, trying to visualize this. I think we're good here. Let's see. I'm going to put the other 2 on the other side. So I have 22.8% phosphorus, and then I have 47.0% oxygen. Okay. Now, in order to start this, we just have to make sure that every percentage is accounted for. We have to add up all of these and just make sure that it is equal to 100%. And if we do equal them up, it will be equal to 100% in this case. So we are good to go. So the first thing is, how do we go from a percentage to grams? Well, this is based on a little bit of assumption, right? The total percentage, like we just said, was out of 100%. So we can say that the total gram sample is 100 grams. So that means that whatever the percentage they gave you was actually equal to the grams that they have. Because if this all equals up to 100% and it all equals up to 100 grams, these are the amount of grams for each individual element. So that's the first step. I'm going to say that 28.7% is really 28.7 grams of potassium. 1.5% hydrogen is really 1.5 grams of hydrogen. 22.8% phosphorus is the same thing as 22.8 grams of phosphorus. And then 47.0% oxygen is really 47.0 grams of oxygen. And the first step is done already. Now we got to move on to the next one. How do I go from grams to moles? Well, grams to moles, that's just a conversion. Okay, but how do I go from grams to moles, right? Well, we all start with grams, right? Gram, 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 and gram. So, and we're doing a conversion, which means that we have to multiply by some ratio. So I'm just going to multiply by a ratio for each one of them, which means that I just times and then I make that division sign. And with process, right, with practice, right, with conversions, remember the one that you don't want, the unit that you don't want goes on the opposite side. So let's just get into that habit. If I don't want grams of potassium, that goes on the bottom. If I don't want grams of hydrogen, that goes on the bottom. I don't want grams of phosphorus, that goes on the bottom. And I don't want grams of oxygen, so that goes on the bottom. Now what goes on the top? Well, I want to find out moles. So the mole has to go on the top. So for the first one with potassium, since it's grams of potassium, it has to be mole of potassium. I almost put a P there. If it's grams of hydrogen on the bottom, it's mole of hydrogen on the top. Whoop. What happened there? Hold on a minute. Okay. That's a good fix. If it's grams of phosphorus, it's got to be moles of phosphorus. And if it's grams of oxygen, it's got to be mole of oxygen. Okay. But now what are the numbers? That's where the periodic table comes in. We look at the mass numbers, which are the decimal numbers, okay? It's not the whole numbers. The whole numbers, remember, are the atomic numbers, not the mass numbers. And Just know that these mass numbers are your gram values, okay? So when you're doing your conversions, those numbers always go with the gram unit. So, for example, grams of potassium, 30.97. So I'm just going to write that down. Let's just move this over a little bit, 30.97. Grams of hydrogen, 1.008. Grams of phosphorus, 30.97. Whoop. Did anybody catch that mistake? Say, Christina, what are you doing? This is potassium. This is 39.10. And then for oxygen is 16.00. What's the number that goes on the top? If you're using these numbers, you always have 1 mole of that element. So the top number, or in this case the top number, but the mole number is always 1. 1 mole of potassium, 1 mole of hydrogen, 1 mole of phosphorus, and 1 mole of oxygen. Now, cancel out the like units. Grams of potassium cancels out with grams of potassium, grams of hydrogen, grams of hydrogen, grams of phosphorus, grams of phosphorus, grams of oxygen, grams of oxygen. And look, you're only left with the moles of each individual element. Now, I just want to squeeze this part over a little bit. I think that's good enough. And now let's just calculate. Okay. So, 28.7, we're going to start with potassium first. 28.7 divided by 39.1. I'm going to cut this off after a few decimals, 0.734. And that is mole of K. And maybe I should move this a little bit back over just so that yeah, okay. Let's do hydrogen, 1.5 divided by 1.008. I get 1.488 moles of hydrogen. 22.8 divided by 30.97. I get 0.736. And that's mole of P. And then 47 divided by 16. I get 2.94. And that's mole of O. Okay, and this step is done. Halfway there, guys. Now we got to get that mole ratio. Well, we were kind of talking about ratios over here, right? Conversions are just using ratios. And when we make a ratio, we just have to divide, right? So I'm going to have to take all of these numbers and divide by something. That's how we make a ratio. So 0.734 divided by something, 1.488 divided by, 0.736 divided by something, and then the 2.94 divided by, right? And maybe I'm just going to, let's see. Maybe I'll just put it up there. Okay. But now, divide by what? Well, the empirical formula is the most simplified formula with the smallest subscripts. So go with this small idea. All you have to do to go from a mole to a mole ratio is you're going to divide by the lowest number. So I have to look at all 4 of my numbers and see which one is the smallest. So I scan. These two are pretty similar, but this one wins by, 2,000ths, right? So I'm going to divide each one by 0.734. 0.734, 0.734, 0.734. Okay. And now I'm going to write my new values down here. So this would cancel, right? Technically, I have 1 mole of potassium. Okay. Let's work on the hydrogen next. 1.488 divided by 0.734. I get very, very close, right? Technically, I get 2.027 and then yada, yada, yada. But this number, at this stage of the game, you want to round to whole numbers if you can. So this is really just 2 moles of hydrogen. Let's move on to the next one. 0.736 divided by 0.734. You probably know what this one's going to be. Very, very, very close to 1 So 1 mole of potassium. Actually, no, P is phosphorus. I swear they put this with potassium and phosphorus to mess you up, right? And then let's do the last one. 2.94. 2.94 divided by 0.734. Very, very, very close to 4 moles of oxygen. And now this step is done. I have 1 mole of potassium, 2 moles of hydrogen, 1 mole of phosphorus, and 4 moles of oxygen. Now we just have to take these numbers and put it into our empirical formula. Well, start from left, go to right. I have a potassium, I have a K, and I have only 1 of them. You can put a 1, but technically you don't have to. Then I have hydrogen. I have 2 of them, so I have to say I have 2. I have 1 phosphorus, so I put a P there. And then I have 4 oxygens, so O4. And that is your empirical formula. If you've noticed, you can't simplify this formula anymore. Since you have subscripts that are 1, you can't divide anything by 1, right? Or anything more than that number, because you'll get a decimal, and we don't want that, or a fraction. And this part is done. There we go, guys. What'd you think? Hopefully this helped. If you guys remember this 4-step process, you guys will do great, all right? I believe in you guys. You guys rock. Keep studying hard, and I'll see you guys in the next lesson. Have an awesome day, and yeah, let's do well on those quizzes and exams and on our homework, okay? I believe in you guys. See you in the next lesson.